probably instructive to answer part F before we look at the values of A, B, C, D, and E. So here's the original function, depending on two variables, x and y. And if you take the inverse sine of some expression, that expression has to be between 1 and -1, because the sine of any angle is between -1 and 1. So this has to be true. X plus y minus 2 has to be between -1 and 1 inclusive. I add 2 to all three pieces of the compound inequality. I can break that apart like this. X plus y has to be greater than or equal to 1, and x plus y has to be less than or equal to 3. And if I solve for y, that tells us that the boundary is the line -x plus 1. That's this blue line right here. Y has to be above that line. And y has to be less than or equal to -x plus 3. That's this line right here. Less than that. So all the points in here are the ordered pairs that make this inequality true. But at the same time, 2x plus 3y minus 6 also has to be between -1 and 1. If we go through the same routine, we can see that the boundary is -2/3 x plus 5/3 for one of the boundaries, and y has to be above that, and y has to be less than this boundary right here. And so this strip is the points of intersection that also have to be true. But we need the intersection of those 2 points, and that's what this is right here, this parallelogram looking thing. And to find out what these points of intersection are, you'd have to find the points of intersection of all these boundaries, probably using the substitution method. So this orange parallelogram contains the set of points that are in the domain of the Q function, including the boundary points along the boundary. So now that we've answered that, let's go to board 2 and talk about Q of xy equals the inverse sine of plus the inverse cosine of these two different expressions. So if a point is in this domain, we should get a defined value. And you can see that 3, 0 right here is in the domain, and I did get an answer. Here's how I might figure that out manually. Q of 3, 0, 3 for x, 0 for y. 3 plus 0 is 3 minus 2 is 1, so the inverse sine of 1 happens to be pi over 2. Think of the unit circle. And the inverse cosine of 3 here is 6 plus 0 minus 6 gives us 0. And the inverse cosine of 0 is also pi over 2. If you add those together, you get pi, and that's what this is right here. Okay. For points that are not in the domain, notice how Q of that x and that y give us an undefined value. Here's 0, 0, not in the domain. Doesn't give us an answer. -1/2, 2 works. I won't, again, substitute -1/2 x, -1/2 for x and 2 for y, and do just what happened here. And you'll see that you get 2.6179939. I forget what that is. This answer right here is pi over 2. But here's a point 3, -1/2. 3, -1/2. That little point right there is not in the domain. That's why it's undefined. 0, 2 is in the domain right there. We get an answer. And even here, I added an extra pair of x and y coordinates. -3, 4.1 is that point right there. I substitute those values into this function and use a calculator. I can find out that the value is 0.1433. Okay, there you go. Hope that helped. If you have any questions, post a comment.